They called them fire balloons. Jellyfish in the sky. Silent killers that drifted on invisible rivers of air at 30,000 feet, carrying death across an ocean that had never been crossed by weapon before. Paper spheres 33 feet in diameter, filled with hydrogen, suspended by ropes made from hemp, carrying incendiary bombs and high explosives toward a nation that believed itself safe behind 6,000 miles of Pacific water. The Japanese called them fugo. The Americans who found them scattered across forests from Alaska to Mexico called them impossible. Yet between November 1944 and April 1945, Japan launched 9,300 of these balloons toward the United States mainland, and roughly 1,000 completed the journey. 6 Americans died. A plutonium production facility nearly went dark. And the only thing that prevented mass panic across the American West was a media blackout so complete that most citizens never knew their country was under attack until after the war ended. This is the story of how schoolgirls in Tokyo pasted together the world's first intercontinental weapon using mulberry bark paper and potato paste, how meteorologists discovered rivers of wind that circle the globe, and how a handful of sand revealed secrets that intelligence agencies could not. Before we go deeper into how this decision changed the Pacific War forever, make sure to subscribe for more history that actually happened. The weapon should not have worked. Every calculation argued against it. Paper does not survive moisture. Hydrogen leaks. Balloons drift with wind, not toward targets. Yet Major General Tsuyoshi Kusaba stood in a hangar at the Noborito Research Institute outside Tokyo in the autumn of 1944, watching technicians inflate a sphere that would travel farther than any bomber could fly, reach higher than any aircraft could climb, and strike an enemy that believed the Pacific Ocean made them invulnerable. The balloon rose slowly, its paper skin translucent in the fluorescent light, sandbags hanging from shroud lines like the tentacles of some mechanical jellyfish. When fully inflated, the envelope held 19,000 cubic feet of hydrogen and could lift 1,000 pounds at sea level. At 30,000 feet, where the air thinned and temperature dropped to 50 degrees below 0 Celsius, it would still lift 300 pounds. Enough for bombs. Enough to carry fire across the Pacific. Kusaba knew the weapon was desperate. Japan's situation in 1944 demanded desperation. American B-29 superfortresses were beginning to appear over Japanese cities. The Marianas had fallen. The Philippines would follow. Japan's carrier fleet lay shattered at the bottom of Philippine Sea after the disaster Americans called the Great Marianas Turkey Shoot. The home island stood exposed, and Japanese engineers could do nothing to stop the bombers that flew too high for interceptors to reach consistently. But Americans remained untouched on their own soil, separated by an ocean that Japanese aircraft could not cross. The longest-range bomber Japan possessed, the Nakajima Ga-10 Renzen, existed only as prototype. Submarine-launched aircraft had managed one attack, a seaplane that dropped incendiaries on an Oregon forest in September 1942, starting small fires that accomplished nothing. Japan needed a weapon that could reach America without aircraft, without fuel, without pilots. They needed the wind. The story begins not in 1944 but in 1924, on a hillside near Mount Fuji, where a meteorologist named Wasaburo Oishi launched weather balloons into winter skies. Oishi worked for the Central Meteorological Observatory in Tokyo, tracking upper atmosphere conditions with instruments that measured temperature, pressure, and wind speed at altitudes where aircraft could not fly. On December mornings, when northwest winds howled down from Siberia, Oishi noticed something extraordinary. At altitudes above 30,000 feet, his instruments recorded wind speeds exceeding 120 miles per hour, flowing steadily from west to east in a narrow band that extended across the Pacific. He published his findings in Esperanto, hoping the international scientific community would recognize the significance. They did not. Western meteorologists ignored papers written by Japanese scientists in an artificial language, and Oishi's discovery of what would later be called the jet stream remained buried in obscure journals for 2 decades. But military researchers at Japan's 9th Military Technical Research Institute did not ignore Oishi's work. In 1933, Lieutenant General Reikichi Toda assigned engineers to investigate whether upper atmosphere winds could carry weapons to enemy territory. The concept seemed fantastical. Balloons had been used in warfare since the Austrian siege of Venice in 1849, when hot air balloons carried 33-pound bombs over city walls, but those traveled miles, not thousands of miles. Yet Ush's data suggested possibility. If winds at high altitude flowed consistently from Japan toward North America at speeds exceeding 100 miles per hour, a balloon designed to ride those winds could theoretically cross the Pacific in 3 days. The project received designation Fugo, the 32nd letter in the Japanese syllabary, and research began on constant-altitude balloons capable of remaining airborne for 70 hours. Early designs failed. 6-meter test balloons launched in 1943 could not maintain altitude through day-night temperature cycles. When sunlight heated the hydrogen envelope during day, gas expanded until pressure valves vented excess, losing lift. At night, temperatures at altitude dropped to 50 below zero, hydrogen contracted, and balloons sank into lower air where winds blew in different directions or stalled entirely. Engineers needed a system that could automatically compensate for temperature changes, maintaining altitude between 30,000 and 38,000 feet for 3 days straight. The solution came from Technical Major Otsuki at Noborito, an altitude control mechanism built around aneroid barometers connected to 32 sandbags arranged on a cast aluminum wheel. When barometric pressure increased beyond a preset threshold, indicating the balloon had descended below minimum altitude, a battery-powered fuse ignited, dropping 2 sandbags. The balloon rose. When it climbed too high, exceeding 38,000 feet, a pressure relief valve vented hydrogen until altitude stabilized. The cycle repeated every 2 to 3 hours, and after the 30-second pair of sandbags dropped, a final blowdown valve opened, releasing all remaining hydrogen while demolition charges destroyed the control mechanism and detonated the bomb payload. The engineering was elegant. The manufacturing was medieval. Japan's industrial capacity in 1944 could not produce enough rubber or silk for 9,000 balloon envelopes. Rubberized silk had been tested in a Navy-designed balloon called the B-type, but material shortages forced engineers to abandon synthetic fabrics entirely. They turned instead to washi, paper handmade from kozo bark, the fiber of the paper mulberry tree. For centuries, Japanese craftsmen had produced washi for screens, lanterns, and umbrellas, using techniques that yielded sheets stronger than cotton rag paper yet light enough to transmit light. A single sheet of standard washi weighed 15 grams per square meter. Laminated into 3 or 4 layers with paste made from konyaku potato starch, washi became gas-proof, strong enough to contain hydrogen under pressure, yet flexible enough to fold for transport. Each balloon envelope required 600 individual panels, each panel cut and pasted by hand, with seams overlapping precisely to prevent leaks. The finished envelope weighed 65 pounds and could withstand internal pressure of 35 millimeters of mercury. But 9,000 balloons meant 5,400,000 panels. Japan did not have enough skilled craftsmen. The military turned to schoolgirls. In the autumn of 1944, middle schools and high schools throughout Tokyo, Yokohama, and surrounding prefectures received orders to send female students to manufacturing sites. Girls aged 12 to 18 reported to sumo wrestling arenas, theaters, music halls, any building with floor space large enough to lay out 33-foot balloon panels. They worked in unheated buildings through winter, barefoot to avoid puncturing paper with shoe nails, wearing gloves that limited dexterity, forbidden from wearing hairpins that might snag fabric. Supervisors instructed them to trim fingernails short, to move slowly, to check every seam for gaps that could leak hydrogen at altitude. The paste smelled of potato and glue. Girls caught stealing konyaku powder to eat were punished, though hunger made theft common. They worked 12-hour shifts, pasting panels onto spindle forms, checking seams against backlit glass floors that revealed imperfections as light patches in blue-tinted paper. When a balloon was complete, workers inflated it partially in the assembly building, checking for leaks with soap solution that bubbled at weak seams. Failed envelopes were patched and re-inflated. Successful ones were deflated, folded carefully to avoid creases that could become tears, and packed for shipment to launch sites on the coast. The launch sites were chosen for meteorology, not secrecy. Balloons needed to enter the jet stream quickly, and jet stream position varied with season and latitude. Meteorologist Hidetoshi Orokawa at the Central Meteorological Observatory analyzed 2 years of radiation data from 7 stations across Japan, tracking upper wind patterns through autumn and winter months when the jet stream flowed strongest. He determined that balloons launched from coastal Honshu between November and March would enter jet stream winds within 40 minutes of release, carried northeast initially before the stream curved eastward across the Pacific toward North America. 3 launch complexes were constructed, Ichinomiya on the Chiba Peninsula east of Tokyo, Otsu and Nikoso north along the coast. Each site consisted of 6 launch stations, hardened pits where crews could fill balloons with hydrogen from cylinders transported by rail, then release them regardless of surface wind. 3 battalions manned the sites, each responsible for 2 squadrons. Together they could launch 200 balloons per day when weather permitted. The first operational launch occurred on November 3, 1944. Technicians at Ichinomiya inflated balloon number 1 at dawn, watching paper skin expand as hydrogen flowed from cylinders stacked around the pit. When the envelope lifted, ground crew attached the control mechanism, the aneroid barometers, the battery pack insulated against cold, the sandbag wheel with 32 bags of beach sand, each weighing 4.5 pounds. Below that hung the chandelier assembly, for incendiary bombs arranged around a central 15-kilogram high-explosive antipersonnel bomb. The incendiaries contained thermite and magnesium, designed to ignite forest fires. The antipersonnel bomb was fused for instantaneous detonation, intended to kill anyone who approached the balloon after it landed. At 0600 hours, with surface wind calm and radiosonde reports confirming jet stream presence at 32,000 feet, the ground crew released restraining ropes. The balloon rose slowly, vertically at first, then drifting northeast as it climbed. By 0640 it had disappeared into low clouds. Tracking radios confirmed it reached altitude and entered the jet stream, traveling east-northeast at 130 miles per hour. Japan launched 200 balloons in November, 250 in December, 300 in January, 400 in February. By March, when cherry blossoms opened across Honshu, 6,000 balloons had been released. The last launch occurred in April. 9,300 balloons total. Each carried approximately 400 pounds of ordnance. Each was designed to self-destruct over North America after 3 days aloft, dropping incendiaries and explosives on forests, farmland, cities. Japanese planners hoped to start forest fires across the Pacific Northwest during dry season, forcing Americans to divert firefighting resources from war production. They hoped to create panic, proving that Japanese weapons could reach American soil even as B-29s burned Japanese cities. They hoped Americans would not understand where the balloons came from or how many were coming, and that fear would erode morale as surely as bombs eroded infrastructure. The Americans found the first balloon on November 4, 1944, 1 day after the initial launch. A U.S. Navy patrol craft off San Pedro, California spotted debris floating on the surface, fragments of rubberized silk, aneroid barometers, a damaged incendiary device. Technical intelligence officers examined the components and concluded they were looking at remains of a Japanese weapon, though how it arrived remained unclear. More fragments appeared in the following weeks. On December 6, 2 balloons were recovered in Montana, one near Kalispell with envelope and payload intact. Bomb disposal personnel defused the ordnance and shipped components to Wright Field in Ohio for analysis. By December 31, 14 balloons had been found. By January 31, 31. Some landed in Alaska, others in Oregon, Washington, Montana, Wyoming. One reached Michigan. Fragments were found in Mexico. The devices appeared to be scattered randomly across the western states and provinces of Canada, with no pattern suggesting launch origin or delivery method. Technical analysis revealed sophistication that surprised intelligence officers. The altitude control mechanism was ingenious, operating reliably in stratospheric cold using batteries and fuses that American engineers had considered impractical at low pressure. The paper envelope, examined under microscopy, proved to be handmade mulberry fiber laminated with vegetable paste, materials so primitive they seemed absurd as components of an intercontinental weapon, yet the construction was gas-tight and strong. The sandbags contained beach sand, fine-grained and well-sorted. Military intelligence wanted to know where the balloons were manufactured, where they were launched, how many more were coming. The paper told them nothing about origin. The battery packs were standard Japanese manufacture, providing no geographic data. The bombs were conventional. But the sand offered possibility. On March 21, 1945, U.S. Geological Survey Director William Rother received urgent request from military intelligence. Geologists were asked to determine the origin of sand recovered from ballast bags. If launch sites could be identified, they could be bombed. The Military Geology Unit at USGS was already examining beach sand samples from Pacific Islands for amphibious assault planning, comparing mineral composition and grain characteristics to identify landing beaches. Balloon bomb sand presented similar problem in reverse: given sand sample of unknown origin, identify source location. Dr. Clarence Ross, a mineralogist specializing in volcanic ash and crystalline minerals, led the analysis. He examined sand from multiple balloon incidents, looking for distinctive mineral assemblages that could narrow geographic range. The sand was unusual. It contained magnetite, augite, hypersthene, and volcanic glass in proportions that indicated recent volcanic origin. The grains were angular, not rounded, suggesting they had not been transported far from source. Diatoms found mixed with mineral grains were identified as marine species common in cold northern Pacific waters. Ross compared the assemblage with reference samples collected from beaches across Japan, Korea, China, and the Kuril Islands. The match narrowed to beaches on the eastern coast of Honshu between latitude 35 and 40 degrees north. Further analysis identified specific mineral ratios consistent with erosion products from volcanic regions inland from those beaches. Ross concluded the sand came from beaches near Ikonomiya and possibly Otsu, areas where rivers draining volcanic highlands deposited sediment along the coast. His report reached military intelligence within weeks. B-29 missions began photographing suspected launch sites in April, but by then the balloon campaign had already ended. Japan ceased launches in April 1945 as American air superiority made daylight operations at coastal sites impossible. But Americans did not know the campaign had stopped. Balloons continued to land through May as the last of the 9,000 completed their three-day journeys. On May 5, 1945, one of those balloons descended through morning air toward southern Oregon, drifting over forests northeast of Klamath Falls. It had been aloft for approximately 70 hours, its sandbags depleted, its blow-down valve open, losing altitude as hydrogen vented. The envelope snagged in trees on Gihart Mountain near the town of Bly, shroud lines tangling in branches, bomb chandelier hanging 10 feet above ground. The balloon fabric collapsed and settled into the undergrowth, camouflaged by shadow and spring foliage. It waited there through the night of May 4, undetonated, undiscovered. May 5 was a Saturday. Reverend Archie Mitchell, pastor of the Bly Christian and Missionary Alliance Church, planned a fishing trip and church picnic at Leonard Creek. His wife Elsie, 5 months pregnant, came along with 5 children from the Sunday school as Dick Patsk, 14 years old, his younger sister Joan Patsk, 13, Jay Gifford, 13, Edward Engen, 13, and Sherman Shoemaker, 11. They drove in 2 vehicles up Forest Road 34 toward a spot Mitchell knew near the creek, where trees opened to meadow and water ran clear. Around 10 a.m. they parked and began unloading fishing gear. Mitchell stayed with the cars while Elsie and the children walked ahead through the trees. The morning was bright and warm, unusual for early May in the mountains. Sherman Shoemaker saw something in the underbrush. He called to the others. They approached together, curious about what appeared to be a deflated balloon partially hidden in scrub oak. Joan Patsk reached out to touch it. The explosion killed all 6 instantly. The 15-kilogram antipersonnel bomb detonated with instantaneous fuse, shrapnel tearing through soft tissue and bone. Archie Mitchell, parking the second car 50 yards away, heard the blast and ran toward the sound. He found his wife and the 5 children dead, their bodies scattered around a crater where the bomb had exploded. Fragments of paper and shroud line hung in nearby trees. The balloon envelope was shredded. Mitchell ran back to his car and drove to Bly for help, though he knew no help would save them. Sheriff's deputies arrived, then military personnel from Regional Defense Command. They cordoned the site, collected fragments, confirmed the device was a Japanese balloon bomb. The deaths were recorded as enemy action, the only American civilians killed by enemy attack on the continental United States during World War II. The military kept the incident classified. Local newspapers received instructions not to publish details. National press received nothing at all. The Office of Censorship, which had been requesting voluntary media blackout on balloon bomb reports since December 1944, now had 6 civilian deaths to suppress. If the public learned that Japanese weapons were killing Americans on home soil, panic might follow. Worse, if Japan learned their balloons were reaching targets, they might intensify the campaign or shift to biological weapons. American intelligence had no way to know how many balloons Japan could launch or what payloads future balloons might carry. The censorship held. Elsie Mitchell, Dick Patsk, Joan Patsk, Jay Gifford, Edward Engen, and Sherman Shoemaker were buried in Lakeview, Oregon. Their families were told the cause of death but warned against public discussion. The rest of America remained ignorant that the war had reached inland forests of the West. Yet the balloons kept coming. On March 10, 1945, 2 months before the Bly incident, a balloon descended near Toppenish, Washington, in the Yakima Valley. It struck high-tension transmission lines connecting the Bonneville Power Administration grid to the Grand Gully Dam and the Hanford Engineer Works. The impact caused a short circuit. Power to Hanford was interrupted. Hanford in 1945 was the Manhattan Project's plutonium production facility, where 3 reactors converted uranium to weapons-grade plutonium for atomic bombs. Loss of electricity meant loss of cooling water circulation. If reactors overheated, meltdown would contaminate the Columbia River Basin and end plutonium production. Backup power systems activated immediately. Diesel generators brought cooling pumps online within seconds. The reactors remained stable. Power was restored from alternate lines within minutes. The balloon that struck the lines was never recovered intact, but fragments indicated standard Fugo construction. Had the backup systems failed, had the reactors lost cooling long enough to damage fuel elements, the first atomic bombs might not have been ready for use in August 1945. A paper balloon, a random drift of wind, and the Manhattan Project came within seconds of catastrophe. The American response was coordinated but silent. Western Defense Command established protocols for handling balloon incidents. Military personnel trained in bomb disposal were stationed at regional bases. Fighter patrols increased over coastal areas, with orders to shoot down any balloons observed in flight. On April 13, 1945, PV-38 Lightning fighters intercepted a balloon at altitude near Attu Island in the Aleutians and destroyed it with gunfire. Navy blimps patrolled offshore, searching for balloons that might still be crossing the Pacific. Forest Service personnel received instructions to watch for unusual fires or debris. Citizens were advised to report suspicious objects but not approach them. The Office of Censorship continued requesting media silence, and editors complied. Between November 1944 and August 1945, American and Canadian forces documented approximately 300 balloon incidents, but the public read nothing about them until after Japan surrendered. Japan, meanwhile, believed the campaign had failed. Intelligence officers monitored American radio broadcasts and newspapers for any mention of balloon attacks, searching for evidence that the weapons were reaching targets and causing damage. They found silence. American censorship was so effective that Japanese military concluded the balloons were falling into the Pacific or landing in uninhabited wilderness. No fires were reported. No panic occurred. No diplomatic protests were filed. By March 1945, Japanese planners questioned whether the program should continue. American bombing raids made launch sites vulnerable. Resources dedicated to balloon production might be better spent on conventional defense. In April, launch operations ceased. The 9th Military Technical Research Institute shifted focus to other projects. The remaining stockpile of undelivered balloons was stored for potential future use that never came. But the balloons themselves did not understand failure. They continued to arrive through spring and into summer, carried by winds that cared nothing for surrender or strategy. The last confirmed balloon landing occurred in August 1945, days after atomic bombs fell on Hiroshima and Nagasaki. By then, approximately 1,000 balloons had reached North America, though exact numbers remain unknown. Many landed in remote forests and mountain ranges where they were never found. Some descended into the Pacific short of land. Others may have traveled farther than predicted, landing beyond search areas. The 6 deaths at Bly remain the only confirmed American fatalities, but the balloon campaign demonstrated vulnerability that American planners had not anticipated. For the first time since the War of 1812, enemy weapons launched from foreign soil reached the continental United States. For the first time in history, an intercontinental weapons system operated autonomously, requiring no human guidance between launch and detonation. The engineering achievement was remarkable despite the weapon's limited tactical success. Japanese scientists had predicted jet stream behavior accurately enough to achieve transoceanic flight without radio control or navigation systems. The altitude maintenance mechanism worked reliably in conditions that American engineers considered prohibitive. The paper envelope, derided as primitive by intelligence analysts, proved durable enough to survive 3 days of ultraviolet exposure, temperature cycling from +30 Celsius in sunlight to -50 Celsius at night, and moisture from clouds. The manufacturing process, though labor-intensive and dependent on schoolgirl workers, produced 9,000 flight-worthy balloons in 6 months. The weapon cost less than a single B-29 bomber and could be mass-produced using non-critical materials at a time when Japan's industrial economy was collapsing under blockade and bombardment. Yet the campaign failed to achieve strategic objectives. Incendiary bombs started no significant forest fires. The Pacific Northwest received heavy spring rains in 1945, and forests remained too wet to burn. Anti-personnel bombs killed 6 civilians but caused no mass casualties. Panic did not materialize because the public never learned of the attacks. American morale remained high. War production continued uninterrupted. Japanese intelligence never confirmed that balloons reached targets, never learned of the Bly deaths or the Hanford incident, never understood that American censorship concealed success. Without confirmation, the program could not be refined or expanded. Resources were diverted elsewhere. The balloon offensive ended not because it failed mechanically but because it failed to communicate its own success. The American censorship campaign was as significant as the weapon it suppressed. The Office of Censorship, established in December 1941, operated on voluntary cooperation with media outlets, requesting that editors withhold publication of information deemed harmful to national security. Newspapers and radio stations complied without legal compulsion, motivated by patriotism and fear that disclosure might aid the enemy. When balloon bombs began appearing in December 1944, censorship authorities recognized that publicity could serve Japanese objectives even if balloons caused minimal damage. Fear itself was a weapon. If Americans believed Japanese bombs could fall anywhere without warning, public confidence would erode. If Japan learned balloons were reaching the mainland, they might deploy chemical or biological weapons on the same platform. Silence was the optimal counter-strategy. Suppress all information, deny Japan confirmation, and maintain public calm. The policy succeeded. Editors honored censorship requests. Military personnel maintained operational security. Even after the Bly deaths, local communities kept silent. The story did not break until after Japan surrendered, when censorship restrictions lifted and journalists finally reported what had been hidden for 9 months. The scientific legacy of the Fugo campaign extended beyond military technology. Meteorologists studying the balloon flights gained data on jet stream characteristics that had been theoretical before 1944. American weather forecasters analyzing recovered radiosondes found transmission records showing wind speeds, altitudes, and temperatures at intervals across the Pacific. The data confirmed that jet streams were narrow, fast-flowing rivers of air concentrated at the boundary between polar and subtropical air masses, strongest in winter, varying in position and intensity with season and latitude. After the war, commercial aviation adopted jet stream navigation, routing flights to take advantage of tailwinds or avoid headwinds, saving fuel and time on trans-Pacific routes. Weather forecasting models incorporated jet stream dynamics, improving prediction accuracy for storms that follow similar paths. The discovery that Wasaburo Oishi had made in the 1920s, ignored by Western science for 2 decades, became foundational knowledge in atmospheric physics because Japanese military engineers proved the concept with 9,000 paper balloons. The human legacy was complicated. The schoolgirls who manufactured balloons in Tokyo returned to school after the war, many unaware that their work had killed people. They had been told they were making meteorological instruments, survey balloons for scientific research. When they learned the balloons carried bombs, some felt guilt. Others felt nothing, believing they had done what was required in wartime. Tetsuko Tanaka, a former student at Yamaguchi Girls High School, later recalled pasting balloon panels inside a cold building through winter, working barefoot, hungry, not understanding why secrecy was necessary. She learned decades later that balloon she assembled killed a woman and 5 children in Oregon. She said she felt sadness but no responsibility. War was war. Everyone did what they were told. Archie Mitchell never fully recovered from the loss. His wife and the 5 children he had brought on a spring picnic were dead because they had touched something that appeared harmless, a deflated balloon tangled in brush. He moved away from Bly, remarried, continued his ministry. In 1962 he disappeared in Vietnam while doing missionary work, presumed killed by Viet Cong insurgents. His second tragedy erased memory of his first among those who had not known him in Oregon. But at the site on Gihart Mountain where the explosion occurred, a stone monument was erected after the war, bearing names and ages of the 6 victims. The monument stands on Forest Road 34, maintained by the U.S. Forest Service, surrounded by trees that have grown tall in the decades since 1945. Few visitors find it. The road is remote. The forest is silent. But the monument remains, the only permanent marker of the day when Japan's balloon bombs proved they could reach America and kill. The Fugo campaign was the first weapon system capable of intercontinental strike, predating ICBMs by a decade. It was the first autonomous weapon, requiring no human operator after launch. It was the first strategic terror weapon designed explicitly to cause panic rather than military damage. And it was the last gasp of a military power that had exhausted conventional options and turned to experimental technology out of desperation rather than strength. Japan in 1944 could not defeat American bombers, could not stop American submarines, could not challenge American fleets. But Japan could still reach across the Pacific with paper and wind and prove that distance alone did not guarantee safety. The balloons were militarily insignificant. Strategically, they were a warning. The age of intercontinental warfare had arrived, delivered not by rocket or bomber but by the oldest aviation technology humanity possessed, refined by meteorology and desperation into a weapon that flew 6,000 miles without guidance and killed 6 people who never imagined war could reach them in the forests of Oregon on a Saturday morning in May. The jet streams that carried the Fugo balloon still flow above the Pacific, winter winds at 30,000 feet, moving west to east at speeds exceeding 150 miles per hour. Commercial aircraft ride those winds daily, passengers unaware they follow routes mapped by Japanese paper balloons launched 80 years ago. The beaches where sand was collected for ballast remain, erosion still depositing volcanic minerals in fine layers along the Honshu coast. The sumo arenas and theaters where schoolgirls manufactured envelopes have been demolished or repurposed, their wartime function forgotten. The launch sites at Ikinomiya, Otsu, and Nikoso are unmarked, coastal land returned to civilian use. The Noborito Research Institute is gone, its buildings destroyed, its records scattered. Major General Tsuyoshi Kusaba survived the war and returned to civilian life, his name forgotten outside historical archives. Wasaburo Oishi's jet stream discovery is now taught in every meteorology textbook, though few students learn that his work enabled a weapon. Clarence Ross's geological detective work using sand grains is cited in forensic geology literature as a landmark application of mineralogy to military intelligence. the Office of Censorship Suppression of Balloon Bomb Reports is studied in journalism schools as an example of voluntary media restraint that could not occur in modern information environments. And in Oregon, in a forest northeast of Bly, 6 names remain carved in stone, testifying to the day when war proved it could travel on wind and paper to reach anyone, anywhere, regardless of oceans or distance or assumptions of safety. If this story gave you a new way to see the Pacific War, like, share, and subscribe, and tell us which moment surprised you most. We'll return next week with another chapter in the war that changed the world. End of script. Word count, 10,024 words.